So then let us go to a little bit of a review. And I want to start with a bit of vocab. So here is my lovely circle. And here is something. In the vocab of circles, what is that line called? What's the special word that we use to describe that line? It is indeed, from what I'm seeing in the chat, I do believe we've got it. This is called a chord. Now, something else that I haven't checked before is, well, I have kind of, but let's see if you can remember it. What is this area over here called? What is this big area over here called? In circle geometry, we have different words to describe different things. Aha, so I see a couple of words coming through. It's not a sector. So I'll show you what a sector is in a moment. This is called a segment. And because this is the bigger one, this is called the major segment. And the one at the bottom here is called the minor segment. So a chord breaks up a circle into a major segment and a minor segment. We normally talk about segments a little bit more than we talk about sectors. A sector is basically enclosed by two radii like that. It looks a bit like a pizza slice. So that would be a sector. And we also have a minor sector and a major sector, but that's not really, for the moment anyway, we're going to focus more on segments. Okay, then the other vocab that's important is, what is this curved line called? What do you think that's called? So yeah, it is called an arc, and we also have a minor arc, which is the green one, and then we also have a major arc, which is this one over here. Okay, that is looking good. Now, today, we're going to start talking a little bit more about theorems that have a bit more to do with something called a cyclic quad. And so I just want to do a little intro to what a cyclic quad is. So a quad or a quadrilateral is just a four-sided shape, any four-sided shape. A cyclic quad is a quadrilateral that I can form by having all its vertices on the circumference of a circle. So this would be called the cyclic quad ABCD. It's not a very complicated idea. And the main thing is the quadrilateral has its points on the circumference, or its vertices. So that is a new little bit of terminology that we need to know. And yeah, in order to be a cyclic quad, you have to be able to put a circle through all 4 points where the points fall on the circumference. Just give me a thumbs up if that makes sense to you guys, what a cyclic quad is. Give me a thumbs down if that's a bit confusing. Okay, so a little bit unsure there. Okay, well, let me show you an example of something that's not a cyclic quad. So let's say I have this. So let's draw these lines. And we'll call this A dash, B dash, C dash, D dash. I want to make the claim that this is not a cyclic quad and this is a cyclic quad. Now, what is the difference between my first quadrilateral and my second? Would anybody like to put their hand up and maybe, or give me an audio? Yeah, Fateko, let's go to you. What's the difference that you can see?
Okay, so I think the difference is that at the second circle, the point at D is not at the circumference of the circle. So it's just in the middle. Yeah. And when you draw the circle, the circle doesn't pass through D.
Yeah, perfect. Couldn't have said it better myself. So that's the main difference, right? So you can have different types of cyclic quads in the sense of like the shapes can look slightly different. So let's make one that's all squeezed into one little corner. That is still a cyclic quad, no problem. But you need to focus on the fact that the points are on the circumference of the circle. Whereas in this one of the points is in the middle. It's not on the circumference. Okay. So can I have another little vote? Thumbs up if that feels okay, like you understand what a cyclic quad is. It's just a special type of quadrilateral, and thumbs down if you still feel a bit unsure. It's just some new vocabulary that I want to make sure that every week I introduce a little bit more of the important terminology and words that we use. Don't worry, Connor, as we get into today, I'll point it out again, but it's not super urgent yet. So Noisy, so all 4 points of or corners of the quadrilateral must be on the circumference of the circle for a cyclic quad. Yes. Yeah. Okay. Now let's start by looking at a new theorem for today. And the new theorem I'm going to draw for you, and then we're going to look at one of these funky little visuals. For Teko, don't worry, I will come back to it. But for the moment, let me talk about this new theorem, and it's called angles in the same segment. So that's the fancy word for it, but I'll explain how it works first. So if you look at my little animation thing on the left-hand side, you will see that one of the lines is red. Now, what is that red line called, or red curved line called? Yeah, it's called an arc. Now, you could also connect these 2 points with a chord, and the chord would divide the circle up into a segment on the one side, like a major segment, and a segment on the bottom, which is the minor segment. Okay, so nothing too exciting yet. Now, this is what the theorem says, and I'll demonstrate it to you. If you've got a chord or an arc that is acting as the base, and it subtends an angle at the circumference here, and it subtends another angle at the circumference here, so these were the 2 angles, then those 2 angles will in fact be equal. So let's just see what this work looks like in an animation. Now that's kind of weird. Look at how it's got nothing to do with the center of the circle, and look at how I can sort of move these along. The only thing that seems to be staying constant is the red arc or the red chord at the bottom. So that's kind of weird. Now, I'm not doing proofs in this particular 6-lesson course. The proofs, we'll do it a later one later in the year with the converses, but that's an interesting theorem. Now, this theorem has a nickname. Does anybody think they can figure out what the nickname of this theorem is? What does it look like to you? If you had to give it a name. So actually, that's not a bad one. A bow tie, yeah. So a bow tie is actually, I didn't mention that earlier on. So a bow tie or a butterfly. Those are the two. These are the 2, like the sort of short named for a bow tie or a butterfly. And you can kind of see why it's called that, because the shape looks like that. So if you imagine that the theorem says that if you've got this common arc, or the shorthand reason, which is called angles in same segment, that's the reason that we use when we're supporting our claims. And the angles in the same segment comes from the fact that you can imagine this being divided up by this line at the bottom, like that line, and there's a segment, both these angles are on this segment. But I tend to focus a bit more on the arc because it's a little bit easier to stand out. It's a little bit less confusing. Okay, so that is the how the theorem works. Now, there's another way of looking at this, but I just want to do a basic question first. So I want to ask you to find for me, what is the value? We'll ignore the second one. So we'll ignore this one. I want to know, what is x equal to? Yeah. And I think a lot of you are seeing this, that this would be the common arc. And if I know that that angle over there is 40, then according to this theorem, which I'm not proving it for you, but I could, x is 40. So you can see that that is equal to that. So the other thing I want to point out is, can you see that the butterfly is formed by 4 points on the circumference of the circle? So the butterfly, it's not that in maths, all butterflies will have this relationship. The butterfly has to be anchored onto a circle, or essentially be a cyclic quad. It has to be able to form a cyclic quad. That's quite important. The butterfly isn't just like all the butterflies you see in the world now have this property. This butterfly is particular to a circle. Okay, let's go to a slightly harder question. Let's go find me x in this question 2, and then I want you to try and find me x and y in question 3. So what is x equal to? And then in the second, or in the third question, what is x and what is y? Okay, I suppose number 2, you can kind of imagine the arc doing that. And you can see that's 70. And so x is 70. I think that makes sense. Or you can imagine this, well, let me write a bit clearer. You could also visualize the chord between these 2 points being like that, if you wanted to. Okay, now x and y in number 3 is a bit trickier. I would love to hear someone's thinking on number 3. Like, what is the process they were going through when they answered number 3, once you get there? So if you are willing to share your thinking, pop your hand up, and we can have a bit of a chat. And I'm not particularly worried if you're wrong or right. I just want to know, what is the thinking process you're going through? Sapile, I see what you're doing there. So some students have spotted those little arrows, and they are kind of important. They do make things a little bit, yeah. Can we unmute Mosima? What were you thinking, Mosima?
Sir, I was thinking, since we have 50 degrees given to us, well, since I see that the 2 lines are parallel, then it's going to be alternating angles, whereby x is also equal to 50. And then
I totally agree with you.
And then for
before
y,
you get there, let's hold on just a second, because you've got it. But I think I just want to point something out. Just because we learn something new doesn't mean that we forget the old stuff. So we've got that this thing over here is 50, and that doesn't really come from anything except the arrows that are there. And so now we've got that. Now there are other ways to get there, but I like that way because it's quick and easy and it uses that. Okay, Mosima, what were you thinking about y?
sir, for y, since x and y are on the same arc, that means that y will also be 50 degrees.
Okay. You're quite quick with this. Have you done this before? Sure. You are.
No, sir.
Wow. Okay. So let me see if I can point out where that same arc is. In fact, I'm drawing it wrong. Apologies. So I think that would be the arc that we are discussing. And so if you think about that arc over there, that pink arc over there, that gives me that angle, but you can also use that one over here. Now, what's interesting is that the arc doesn't have to be at the bottom. The arc can actually be at the top, and then the angles can be at the bottom as well. So I didn't want to show you that all at once, but it doesn't really matter where the arc is. And so that's why the butterfly shape is quite helpful. And what you also notice is that it's almost like there's a repeated pattern. So like this one over here will always be the same as that one over there. And then even though it's not really a focus in this question, this one up here will also be the same as that one up there. But the blue dots would actually come from a shared arc on the other side of the circle, which I'll point out in the next question. I don't want to do too much at the beginning, but there's definitely the sense that there's a butterfly. The butterfly has its anchoring points on the circumference of the circle, or it's a cyclic quad, and then we get the relationship that forms from there. Okay, let's go to these ones. So I want you to do question 1 and 2 for me. So can you find A and B in question 1 and C and D in question 2? We're not doing reasons at this stage. We're just getting used to the visual patterns and shapes that our brain can translate them. It's too big. Okay, I think I'm making this look a little bit too exciting. B is 30. Okay, A is 27, B is 30. Now, what about C and D? So if I use the green arc, I think that could be very helpful in finding C. And to me, it looks like C has to be 20. And if I use the yellow arc, it looks to me like D should be 45 degrees. So I'm drawing a little bit less cluttered now, just to show you what arc am I using to get each shape. Appealing, here we go. I like it. Aha. Why don't we try and do number 3 as well? Can you find me now? So for number 3, you have to find C, D, and E. And I'll give you a little bit more time. I know I was a bit quick there. That one. Senamile has asked for question 2. the triangles don't look equal. Why are the angles equal for number 2? Okay, that is an interesting question. They don't actually have to be the same size for them to be equal. And the reason is that we're not dealing with radii at the moment. There's no mention of the center of the circle. So the butterfly wings don't have to be the same size for the relationship to exist. It's a really good question. And what I'm going to do is I'm going to go back to my animation later in the lesson just to show you. But the wings don't need to be even for the angles to be equal. Great question. So while we are doing 3, can I ask you also just to try out number 4? We'll give that a go as well, because I can see that the shapes are starting to be a bit clearer. But I'll give some hints on number 3, don't worry. The thing that makes number 3 a bit harder is it feels a bit cluttered. And so what I do is I just go, let me pick one thing. So I'm just going to focus on D if I can. Because everything else doesn't matter until, choose one thing at a time. And if I focus on D, I can kind of see this arc over here could be helpful. So that's going to be my hint for D. And then see if that helps you in other ways. So to me, it looks like D has a relationship with 41. And D has to be 41 degrees. Now, what have we got left? We've got C. What hint can I give you for C? I was thinking for C, couldn't this pink arc be quite helpful? Okay, so let me, for the yellow one, I think that that is 41. And then this one over here is 41. So these two angles are in a relationship. Does that help a little bit about how I got 41? So that's how I get D as 41. No. Okay. So can you see the yellow? Can you see the yellow arc? If you imagine drawing an angle from here, look at how this goes to here. Sorry, it's looking like a Christmas tree, isn't it? Let's take them out. So that angle I know is subtended by the yellow arc, but it can also subtend the angle up here. And so these ones over here will be equal. Now that idea can also be used for the pink arc, except I'm no longer going to focus on D, I'm going to focus on C. So if I just kind of take that idea and I go, look, I'm pretty confident I know what D is, but what angle is in relationship to C? So I think as long as I start, remember I must start on these 2 points. It feels like for me that C is 58 degrees. So I've got 58. And then what have I got left to get? So I can see I'm losing a couple of you from the answers. So we can slow it down. So no need to rush. What have we established so far? We know that this and this one are 41. And that was using the yellow arc. And then using the pink arc, we said that C and this are 58. Yeah, so I'm going to slow right down here and make sure I've got everyone on board. So, yes, Malimang, let's unmute you. What's your question? Can you maybe, Maliman, can you unmute? So I'm just wondering, so far in question 3, I've got these two over here. Now, the last thing I haven't found is E yet. What angle do you think E is going to go with? What angle is its, I don't say its cousin, but, you know, let me choose a different color because I'm worried my like for all the color is causing confusion, but shout if it's too colorful. But if that was my arc, then it feels like I can get to that one there. And then I can also get to that one there. And so that one goes with that one. And so we say that E is 30. So that was a tough question, hey? So there's no, I mean, I understand this is the first time you've seen it. I don't expect you to get them all, but what I want you to see is the process I'm using as I do it. So I'm going to leave this on the screens. I'm not going to chase it away, but I do want to ask for some people to maybe explain what they were doing in question 4. Would anybody like to come on and just explain their thinking for question 4? Yeah, Mosima, let's go to you.
Sir, for question 4.
Yeah.
I found F to be 40 since these triangles are sharing the same arc.
Okay, so let's start first with F. So if F is 40 and the same arc that they're sharing, would you agree that it's the green one that I'm drawing now?
Yes,
Is that
sir.
the arc that okay.
So,
what
sir,
about, what did you do next?
So to find G,
Yeah.
I said that since F is 40 and we have a degree that's 85.
Yes.
There are sum of angles in a triangle.
Aha. So you notice that this is a triangle. You notice
Yes,
that this
sir.
thing inside the circle is a triangle, and you found G. How?
So I said 180
Yeah.
minus 40
Yeah.
minus 85.
Okay, great. So what was your final answer?
55.
Let me just check it. Yeah, 95 plus 5 is, yeah,
Sorry.
I agree with you.
Yes,
Perfect. Yeah. Well, we've got 2 of the 3. Did you manage to get to H or? Okay, I think we might have lost you there. Fatejo, let's go to you. Did you manage to get H?
Okay, so I also have a question, but let me answer H before I ask my question. So H is also 55 because G is equals to H.
Okay, so you're saying that G and H are the same. I think I see why. Let's just check that I'm using the same arc as you. Did you use the yellow arc that I'm drawing in now to help you?
Yes.
Okay, no, then we're definitely on the same thing. Yeah, so I agree. H is 55. What was your question?
So my question is, when we're finding G, can we use the straight line for 40, 85, and G, which is also going to be the same thing with 180 minus 40 minus 85?
So are you saying, could you find that that's 85? Or is that what, or are you saying work out this angle over here on the straight line?
Yes.
Okay, both of those are fine. So the other bits of geometry don't go away. They're still valid. So this is what we call vertically opposite angles. And if you had worked out this blue one over here, that would have been 95 because of angles on a straight line. So all those ideas still apply. So absolutely fine. You would get 100%, no problem.
Okay, thank you, sir.
Awesome. Everyone, we've done fantastically well. What I want to suggest is we take a quick break. And so take a moment to just relax. And let me see what I want to do this minutes of breathing exercise. So let's see if I can do this properly. So just sit up properly in your seat, and we will listen to this calming voice for a minute.
So sitting comfortably, just taking a big deep breath in through the nose, out through the mouth. As you breathe in, noticing how the body expands. As you breathe out, just watching the body soften as you gently close the eyes. And rather than the mind leading the breath, allow the breath to lead the mind. Notice the sensation of the breath. Notice it where you feel it in the body. If you need to, you can just gently place your hand on the stomach. And just following that rising and falling sensation. Nothing else to do. Allowing thoughts to come and go. And when you're ready, just gently opening the eyes again.
Cool. Oh, they're advertising. Anyway. Cool. Was that, I don't know, was that your cup of tea or not? No judgments either way. It's just a breathing exercise. 6 out of 10. No problem.
We hope it was relaxing, guys.
No. So the idea behind it is that when you're stressed, you can't learn very well. And so if you take a bit more breathing, then your body relaxes and then your brain relaxes too. Beverly says, very relaxing, sir, but too relaxing. We're going to fall asleep. I hear you. Don't worry. I've got antidote for that. Don't worry. But before we get there, can you try and make 24 using these 4 numbers? Okay, so can you make 24 using these 4 numbers? So Rafenza, so what it works on is it works on automating your multiplication, division and stuff. That's the thinking, and also your problem solving. So that's the main idea. But it's also just a fun break too. We don't have to do it always. I just like to try out different things. You know, I'm not against. If you don't like it, let me know. No problems. Oh, Tabojo and Cass. So, there's a couple of ways to do this. So we have 5 times 6 equals 30. And then 30 minus 3 is 24. And then the other way to do it was to say 5 times 3 is 15. And then 15 plus 3 plus 6. I like it. I like it very much. Well done, everyone. Okay, now we've had a little breathing break. We've had a little diversion. You know what's coming next. So stand up and join me. We are going to do a little stretch. And we are going to get our blood rate, heart rate up. But first, let us just do a little bit of stretching. Let's grab this. Grab your opposite elbow. Or your opposite. Who knows? And then it's so weird watching. There we go. Stretch that one. Make sure you're standing up. We know that our body needs things to circulate. So please stand up, and then small circles and bigger circles and windmill circles. Change, you're doing the butterfly at Sports Day in the gala. There we go. Okay, one more quick little thing. We're going to do 5 jumping jacks. The reason we're doing this is we want to get our heart rate up. We want the blood to pump in our body. It really will help us with concentration. So 1, 2, 3. 1, 2, 3, 4, 5. Actually, 6. I'm going to go to 10. 8, 9, 10. Yep. I just couldn't stop myself. My body was like, please get me moving. All right. Let me know in the chat how you're feeling. Do you feel like your concentration span has been reset? And if you have a cool brain break that we could try out, do let us know. I'm always curious to know how people experience it. And because we're online and we have the chat forum, we can get feedback straight away, which is so nice. Beverly, let's go to your question. Hi, Beverly. Hey, how's it going?
I'm good, thanks. And you?
Very good.
So yeah. I wanted to ask, last week, Wednesday, I didn't attend class, so I just watched a video. But then sometimes, like, I don't get links to the quizzes.
Okay. I tell you what, chat to you. Awesome. No, that's a great question, Beverly. Level, can I ask you just to follow up on that as to an admin issue with Beverly, who was just saying, awesome. Thanks for that, Beverly. Oh, and Connor has the same. Okay. So while we're teaching, Level will talk to you about that and we'll go from there. So thanks for letting us know. Okay. Let us see if we can do question number 5. So question number 5, you have to find A, B, and C. And let's also see if we can do question number 6, applying the theorem that we've learned about today so far. Yeah. Maybe just take a screenshot, Level. I can see there's a couple of students, so it might be easier to just do that. Thanks for letting us know, guys. We really appreciate you. Yeah. Okay, so some answers are beginning to come in. B is very popular, and so is A. I think I understand why that is. I'm starting to see the butterfly myself a bit more clearly. So it feels like these are in relationship. So that's an 80. And then it feels like this 32 is related to this one over here, which would be 32 degrees. Now, the harder one is C. Would anybody like to explain how they get to C? Because there's a couple of different answers that are coming through in the chat. Beverly, let's go to you. What do you think the answer to C is?
Sir, so yeah, I did is I worked out the angles, the angles of the interior angles of the bigger triangle. So 80 and 32. And then the missing angle I got.
Okay.
Yeah, I did that.
You did that. Okay. Because I was just guessing, but that's the triangle you used. So
no, not that one.
Oh, not that one.
No, half of that one.
Okay, so let me see. So did it include
no, 80 and 32, the triangle that has 80 and 32.
Oh, 80 and 32. Okay. So let's see, like this one over here.
Yes.
Is that it?
Yes, sir.
Okay. So how did you get to see? Yeah.
And then I said 180 minus 80 minus 32. And then I got that angle that's not there, which was 68. And then I did angles on a straight line. So I said 180 minus 68. Then I got 112. That's the other angle. Then I see 180 minus 25 minus 112. And then I got C is 43.
I hear you. That sounds good to me. Could I ask, is anybody else who did it, got the same answer but did it a different way? I'm curious. Yenzi, what were you thinking?
So what I did was I added the angles 32 and 25, and then I got 57, and then I said 57 plus 80, which gave me 130 something, and then I minus that, which gave me 43. So I used the bigger circle, triangle.
Yeah, so I can think what you did was you said you got the sum of this, which was 57, and then you said, well, in that case, C must be 180 minus 57 minus 80, and we both get 43.
Yes.
Awesome. Well done. So something else to point out, it's not that triangle geometry goes away. The theorems that deal with triangles are still applicable in circle geometry. Often just the triangles are inside circles, which makes them look a bit fancier, but they're still triangles at heart. That was awesome. Well done. Paul, let's go to you. Maybe you've got some answers for the next one or another method.
Hi, sir. So with me, sir, I use the triangle that looks like a right angle triangle, sir. If you see the one with C and A and B and 25 degrees. And then the sum of the angles of the triangles there. And then I just basically subtracted 80, 25, and 32, and then I got that C is 43.
Perfect. What I love about this is you can see there are 3 different ways to get to the answer. They're all perfectly correct. So thank you so much, Yenzi. That was great. Okay, let's move on to number 6. And then I think from what I'm seeing some good understanding here. And we can move on to something, just a preview of the next lesson. But let's try and find what X, Y, and Z are. Yeah, Fateh, let's see what is your, have you got a little bit of guidance to give us? I'm thinking, what question?
Okay, so for solving number 6, I said I first focused on Y. So
Y, okay, down here.
Yes, and then I used the triangle, this triangle,
96?
and yes. So
okay,
I
so
said
yes.
Then I said 180 minus 50 minus 96, which is 34. So Y is 34. And if we look at...
I just want to make sure everyone's with us. So what is being used by Fateh is the fact that these angles, going back to grade 9, are called vertically opposite angles. And so they'll be equal. And then from there, we use the sum of angles in a triangle to get 34. And so you're quite correct. We've got that's 34. Okay, where did you go from there?
Then for finding X, I used the arc at the bottom.
Okay,
and then
so did you use that arc over there?
Yes.
Okay.
And if we use that arc, we can see that Y is equal to X, therefore X is also 34.
Yeah, so I agree, X is 34. Normally in a formal test, we would write reasons. We're leaving them out for now, but that's 34. Okay, Fateh, thank you very much. That is awesome. Has anybody else got Z? Anybody willing to share their thinking on Z? how would we get Z? What have we got enough information to get Z? Yeah, let's go to Cass. Cass, how did you get Z?
Hey, so what I'm thinking
Yeah.
is that on a straight line, it's 180. If you minus 96 from the 180, and you look at the triangle on the right, and sum of triangle is 180 minus 40 minus 84. Wait.
So you got 84 for this line. Is that the one that you were talking about? Did you get 84 there?
Yes.
Okay.
Then the 40 would be on the other side.
Okay.
And then 180 minus those ones.
Perfect. So you did a couple of things there all at once. I just want to point out what Cass did there is she used the sort of butterfly theorem to get, and you can jump in, tell me, Cass, if I'm kind of assuming things, but you basically use this shape to get the 40 over here.
Yeah.
Okay. And so you can see the butterfly shape, that's the 40. And so Z would just be 180 minus 84 minus 40. And what did you get in the end for your answer?
For Z, 56.
56. Okay, that's perfect. Yeah. So as long as that, yeah, we do get 56. Now, I see in the chat, there was a bit of a debate around using alternate angles. Now, we can't use alternate angles here because there are no parallel lines. The Z relationship will only be, the Z angles will only be equal if there are parallel lines, and there are no parallel lines. All we have in this question, we don't even have the center of the circle. To come back to the beginning, all we have is a cyclic quad where we have the butterfly shape in the cyclic quad. And so that's all we've got to work with. That's the only tools for the job. So if you've got a screwdriver and that's all you've got in your toolkit, you have to work with the screwdriver. You just have to use it in whatever way you can. Okay, now we're almost done for today. And okay, a couple of people have asking, can you please re-explain how I got Z? There's a couple of ways to do it. What really was the key thing? Well, there was a couple. The first step in finding Z was to get the 84, which is angles on a straight line. And then it was to realize that this angle over here is 40, and so is this one because of the butterfly. And if you're wondering what arc you used to get that, the arc would have been this one. Or you could have thought of using this chord. Some teachers use either of them. It's not a problem which one. And then once you've got those two, you go 180 minus those two to get Z. So the 84 comes from angles on a straight line. Angles on a straight line have to add up to 180. Okay.
Mr. S, we have a hand from Ian.
Okay, let's go to Ian. What's your question, Ian? How can I help you?
They're not unmuting.
Okay. Okay. Well, you know what? I think we're just about done for today. So let me see. Well, we've got a little bit of time. So let me try and re-explain some of those things. And then, maybe I mute all there if we can. So while let's see, number 7. Okay, no, actually, let's avoid 7 for now. We can talk about another theorem before we can get to that. Let's actually call it a day for today. I think we've done really well. I think let's just do a little recap. So what is today about? So today was about, first of all, knowing this new thing called a cyclic quad, which was at the very beginning, and then knowing that we sometimes get this butterfly shape where we have a cyclic quad and it makes this butterfly shape, and we can use an arc to be the base on which we subtend pairs of equal angles. Now that sounds like a mouthful. What it all really means is that every butterfly in a cyclic quad is going to have two sets of equal angles, and they're going to be on each side of the wings. And so that's the main thing I want you to take from today. But once you have these butterflies, you also have triangles, and triangles have their own properties. And you also sometimes have other shapes that pop up that you can use the properties of. Okay, Fatejo says, I was going to define a cyclic quad again. Let's go back well, let me try and talk about what a cyclic quad is. So all a cyclic quad is when you have a quadrilateral, a four-sided shape where each of the corners are on the circumference of the circle, on the edge of the circle. So that is what we call a cyclic quad. Now, if you have a cyclic quad, it's also possible to have this shape that I showed you today, which is this butterfly shape. And that would say that this angle over here, and I'm doing this very on the fly here, is equal to that angle over there. And when we were getting the blue X's, we basically said that we were using that arc over there to help us to get the blue ones. And then when we're getting for the red dots, we use this arc down here. And that would give me the red angles are equal. I see there's a couple of, I don't like this butterfly. Tomoko, you just have to give it time. It'll become beautiful to you, I promise. You don't understand when I include the arcs. So you don't have to include the arcs, right? So if you take a circle like this, right? So if I do this, a summary of today's lesson at its heart is that this angle over here is equal to this angle over here, and this angle over here is equal to that angle over there. Now, if you want to understand why that is, okay, it's quite helpful to think that the two red dots are angles that are subtended or formed based on the yellow arc. So you can imagine an angle going up there and an angle going up there. And the red X's are formed on the arc, from the arc. And the fancy word we use is subtend, from the purple arc up there. Okay. So now, if we go to the very beginning, this is where we started the lesson. If we look at this little animation, this is what I was trying to show you at the very beginning. Look, guys, I must be honest, my brain takes a while to see visual pictures. So everyone's different in terms of the section. But what I know when I designed the series was I knew I wanted to give students a lot of time to take in the visual information. And then the lessons can come, the reasons can come later. So if you look at this shape, notice how it doesn't matter if the one butterfly wing is really small and the other butterfly wing is really big. Notice how the angle is still 48 and 48. Or notice if I do this, they still stay 48. That is really the main idea that has come through today. Now, I didn't focus on the ones at the bottom, but the ones at the bottom are also going to be equal. It's just that the arc is going to be the one at the top. Okay, everyone, can we do the poll? Sorry, Lebo, I forgot completely. I got so into my explanation. If you could just put the poll out. And the main thing I want to say to you is just give it some time, click save as, come back on Wednesday, and I promise all the shapes will start to make a bit more sense. Cool. Keep that feedback coming.
Mr. East, is it okay if I unmute Nandi? There's a question.
Cheers, everyone. I hope you enjoyed the lesson. I will see you on Wednesday. And yeah, let's unmute. Yeah. Hey, how's it going?
So what we basically learned today was about the butterfly wings.
Yeah.
Parts. All butterfly wings are equal no matter the size, and we also incorporated some of the old stuff we learned in the past about angles on a straight line, some of angles in a... Okay, thank you. So I just wanted to confirm that.
Absolutely. No, it was great. You're right. So we took something new and we kind of made a remix, for lack of a better word. We brought it together. Cool. What other? Tsuboho, let's go to you.
So, hi, sir.
Hey, what can I do?
Does the opposite angles also, are they equal, or
opposite angles, what do you mean? So the vertically opposite angles are equal. So if you're talking about the relationship between these two,
yes.
I think kind of goes away. Those two are equal. Yes, that's like grade 9 learning that we use. Yeah.
Okay. Thank you.
Pleasure.